Hey, how's it going? Well, I've decided to make another video today. Um, and yeah, we're gonna continue our linked list. The reason why is because, well, I have a little bit of time and I want to make up for not posting videos frequently. So here's to you. Okay, so now that we have our insert function and we can check out the contents of our list, we want to be able to remove items, and I'm going to implement three ways that you can remove something. The first one is going to be remove first. So we're going to be removing um, the first node within our list. And we're just going to call it remove first. This one will take no parameters, and it just removes the first item node from our list. The second one is going to remove the last item from our list. And the third one is going to be remove at a certain position, I guess you can say. And this one you can specify a certain number in this case, and if it exists, then it will remove it. If it does not exist, then it will not remove it, and it will return true if it does exist and if it removed it, and it will return false otherwise. So removes node at desired location. Within our list. And then the last thing we'll want to do is to have some kind of way to see if we do have something there. So this searches the list to see if data exists. So with this function, you can do a lot of things. You can use it to, within the remove function, the remove at function, you can find in this case we would want to return a node or reference to a node, and if we do find it, we'll return it, and then we can use that here to delete it. We can also use find just in case if we don't want duplicates in our list. Sometimes, like let's say you have like a list of names or emails, and you don't want emails to duplicate within your list. So you would you would use this function to check if it exists or if it does not exist. And it will return the node if it does, and if it does not, it will return null. Man, it's pretty cold right now. Okay, so first one is remove first. Okay. So first we want to see if we have data in our list. You can either do it like this or say does not equal null. Either way is fine. And then you want to create a temporary node to store the the node that you're gonna delete. So we actually want to start in the start of the list, and you want to move, since we're going to be removing the first one, we want to move our first node pointer, which is the head, to the next node in the list. So you just call head get next. So we know where the rest of the list is, because if we just delete the first one, like I've said in my previous video, you'll lose the whole list and you will not be able to release that memory, and it can cause memory leaks, which is not a good thing. After this, we can just delete our temporary store and just set it to null. And that's that. Now for the last one, it's similar, but instead of using the head pointer, we'll be using the tail pointer. We don't have to search anything here. We do have to check though to make sure that we have something in our list, as always. And then we want to do the same thing. Create a temporary node, assign it to get our tail. actually, yeah, we're gonna have to search on this one. We're gonna have to start from the top because we want to get the previous one. If it were a doubly linked list, then it would have a pointer so we can go backwards. But since it is a singly linked list, makes everything more complicated, and we're gonna have to loop. So if temp next does not equal tail, then we want to not data next. We want to go forward. I'll just use a while loop here. Damn it. Now, at this point, we should have the node that is before the end stored in our temporary. So we should have the second to last node in temp by now. So we can just delete tail and then set tail to temp, and then we'll just set next and set it to null. And that's that for this one. Now, remove at location. It'll be similar to this one because we'll have to loop through each single node, but instead of having just one temporary location, we'll have two. Because we didn't have two temporary locations because we had our tail and heads, so we only needed one storage since we're going to be Since there's a high possibility of them wanting to delete something that's like in between, like in the middle of the list, then you will have to have 2 pointers, because we won't know where the previous one is and where the next one is. So list remove at int data. We have to make sure that we have our head filled up. And then we'll do it this way for now. Temp equals head. Previous is head as well. And then while previous get next get data is not our data that we want to look for, we are going to set previous to what temp is currently, and then we're going to move temp one step forward. And when we get to this point, we should already have what we want to delete stored, and what comes after that is where it is. So our temporary is going to be the one that we want to delete. And the previous one we want to have, let's go back to our little drawing here. So let's say we want to delete this guy right here. We would have to have oh, let's add one more actually. Let's redo this. Okay, so let's say we have 1, 2, 3, and 4. This one is the last one. So we got our head here, we got our tail here. And since we want to delete this guy, our temporary pointer is going to move all the way here, while the previous one is going to move here. What we want to do first is we want to get this link, unlink that, and then link it to this guy so that we know where the rest of the list is before we delete our temporary. So once we do this, once we have this link established to the one after the one we want to delete, then we can delete this dude right here, and that'll be it. So you want to say previous set next, and it's going to be temp get next. Now, there's a potential problem with this, and that problem is if, well, if temp would be the last one on the list, get next would just set it to null, so there shouldn't be any problems. We'll see when we compile. Let's just keep on going forward. After this, we can just delete temp and set temp equals to null. So we can return true here. Success. Otherwise, we can return false. False being nothing got deleted, true something got deleted. Okay. Now the last one is going to be our find thing. We can call it find or search. Does not really matter, just a name that will give people who will be using your structures or classes a name that it's meaningful, and they'll be like, oh, okay. And also documentation. Yeah, I know I'm not doing that, but because I just want to finish this thing. So if we have something in our list, we just want to, we're going to do a for loop on this one. And we're going to start at the top. And we're going to do it until temp is null. And if it's not null, we are going to increase or traverse through it. And then here we want to check to see if the data matches. If it does, then we can just return, wait, not tnode, return temp. If it does not, we just return null, or null pointer. And if it gets to this point, that means there is nothing on the list, so we return an empty, a null pointer. And that is it for this. That is that. Now let's check our functionality. So we're going to leave that as that. The same thing for the for loop, 2 insertions. And the printing, we're going to keep that. And then we're going to do the first one, remove first. And then we're going to do remove last. And then we want to print it to see how it's going. And finally, we want to remove something, let's say 5. Or you know what? We'll remove 5, but we'll just, so we don't have too many prints, we'll just print at the end and run it. See what it does. Okay. Well, before we do that, let's say right here, we're going to add a cout so we know what's happening, because it's all weird. So we'll just say remove first and copy that, remove last, remove at, and I forgot one more, find. Let's find number 3. Okay. Last. We'll just add 5 and find 3. Boom. Run it again. Okay. So what happens first is hold on, is we put in all 10 numbers in here, so that's that. Then we remove first, we remove last, and we remove 5. Then we forgot to do something here. We'll check find in a bit because we are returning a node, so we don't know if it works or not just yet. So removing from this, you can see that it actually worked because 0, 9, and 5 are all removed. They do not exist anymore from this list. Now let's fix this guy. Tnode temp equals, and then just see out instead of doing this guy, we'll delete it and just say find 3 and we'll say temp get data and run it again. Oh, well, finally broke something. Okay. So apparently we have an empty data set. Okay. Stop debugging. And we want to see where it happened. Return node should set a breakpoint there. Okay, we got this, and we're not returning anything. Let's check this guy. Okay, temporaries, no. let's put a breakpoint there and see what's happening here. So we got this. Right now we're in the first element. Well, okay. Where are you? Here we go. Just step over. Okay, so temp is the first guy. Next is 2, and then 3. So I see. What is that? Of course. Okay. So delete this. And we'll just break out of there. Now would I have to? Yeah, I would. I would. Let's cut this out of there. Let's put this thing here. And then we can check here. If temp, well, actually we already checked. So we broke out of there. But, okay. Hold on. Okay, we got data. No. Yeah. Okay. There we go. Sorry, it took me a little bit. I'm kind of sleepy. It is 1 a.m. in the morning. I gotta wake up in 4 hours. Anyway, yeah. So the reason why it wasn't working and it was returning null all the time was because we had it so that we were checking here if the temp data was equal to data, then return this, right? But we also had an else statement that said if it's not, then return null, which if it's not, we don't have to do anything. We don't have to return anything because it's automatically going to get out when temp variable is null. Once it gets out, it'll go all the way down here and we can just exit here anyway. So that is why it was bugging out. It was my fault. We can put this back in here since we don't need it out there. So yeah. So that works now. We should also check before we print if it's not empty. When you're working with pointers, you always want to make sure that they're not empty when you want to use them. Otherwise, you're gonna crash like I did. And I should have known better, but I'm sorry. It is pretty late. Anyway, so everything works. Everything is ready to go. So we can now insert any data we want into our list. We can remove the first node in our list and the last node in our list. We can also remove any data we want. Any data we want. So we can first find it. If it returns a node, we can plug the get data here and remove it. We can also check our, we can also view our list. On my next tutorial, I will be making a program for us to implement a real world situation where you would actually use a list. I want to say I'm gonna make a flight airline ticket because I did it for homework, or we can also make just a user database maybe, I don't know, or something, I don't know. We'll see. If you guys have any suggestions on what that program should be using a linked list, I'm all ears. Alright, I hope you guys learn a lot from this. If you guys still have questions, you can let me know. Yeah. Thank you for watching. I appreciate it. If you liked my videos, please subscribe. And if if you guys have any, any stuff that you guys want to see how it's done in the future, let me know as well. All right. Well, good night.